Hello world, I'm Sherlock Holmes and this is my friend Watson.
Hello Sherlock. I have a mystery for us to solve today.
What is this mystery you speak of?
It's on electromagnetism. You see, when I put this magnet into this solenoid, the magnet on the other end moves up and down.
I wonder how that works.
Let's find out!
First, we must uncover some background information on electromagnetism.
Some useful definitions.
Electromagnetism.
The study of electromagnetism deals with how electrically charged particles interact with each other and with non-magnetic fields.
Electromagnetic induction
is the voltage difference produced across a conductor due to a varying magnetic field or change in magnetic flux.
Magnetic flux
is the number of magnetic field lines intercepted in a given area.
Galvanometer
measures the very small amounts of current. Lenz's law says that an induced voltage in a closed conducting loop always gives rise to a current whose magnetic field opposes the original change in magnetic flux.
Let's do the experiment to find out what really happens.
Alright, so when we enter the magnet into the solenoid, it intercepts the magnetic field lines, which changes the magnetic flux. This change in flux produces a change in voltage, and the change in voltage here produces a current.
But Sherlock, how does this make the magnet move?
This current then flows through the wires into the next solenoid. The current flows in a certain direction, which produces a magnetic field. This magnet then detects the magnetic field and repels, causing the magnet to move. Looking back, if we take the magnet out of the solenoid, it produces a current in the other direction through these wires, and the magnet at this end flows a different way. Another observation we made while conducting this experiment is that the rate of the magnet moving in and out of the solenoid here affects the way the magnet moves here. In order for the two magnets to be in sync with movement, we need to get the current changing at the right rate to change its magnetic field. This rate is determined by the frequency of vibration that the spring likes to vibrate at.
Another observation was the application of Lenz's law. Lenz's law states that an induced voltage in a closed conducting loop always gives rise to an induced current whose induced magnetic field opposes the original change in magnetic flux.
As I enter the magnet into the solenoid, it gives rise to a voltage, which gives rise to an induced current. The current thus produced is going to create a magnetic field that opposes the original magnetic flux. As we enter the magnet, the induced magnetic field will go in the opposite direction, the South Pole.
Alright, this is another mystery solved by the wonderful Sherlock Holmes and John Watson. Until next time!